Why does it stream? Hmm. Yes. All right. It's weird. My streaming auto starts now for some reason. So, not sure why.
So we're live on YouTube.
Apparently. Hi everyone. But anyway, I gotta look into that another time. I'm not gonna stop it because there's a high chance I'll never get started again if I stop it now and whatever. We'll just have the pre-show streaming live before we start. So just watch what you say. Terry, how's it going? Mm,
Going good.
You're an early arriver.
Yeah, I tried to get here. I just we just attended the Vancouver meetup.
Oh, how'd that go?
It was good. I think we had about like 40 people there. Had a couple people um do some presentations, but yeah, it was pretty good.
Nice. Hey, hey Nick. Sorry about the call this morning. I overslept. I shouldn't stay up so late coding. So what can you do, I guess? So oh, he's on a call. Um, yeah, I saw that post from the you were talking about this post from how do you pronounce his last name? Yagi? I don't know.
I think so. Yeah, somewhere there.
Okay, so no one else. 57, eh? Yeah, it's here. I'll pop it. I'll pop the link in here. Hey, the fact other people are trying to create these similar platforms indicates I'm not crazy after all, to be honest. It was, for a while there was no other platforms out there. So that's
Yeah.
that's
What
a
does the new Claude built-in feature of tasks helping Cloudflow, or does it need to change in any way to support
it's
that?
the background workers and tasks work independently of Claude code. So I use my root vector system to invoke those as secondary sort of ephemeral agents. I love ephemeral. It's a great word too. Whatever process. Hey, Peter, I pushed out a new update yet again. There's variances. Like if it worked on my Mac, I don't know why you're having trouble. Are you on a Mac?
Yep. Yep.
Hmm. Well, I did a deep check this morning and pushed in another couple updates. Hopefully your problems are resolved.
No, well, it's
Might
an
might
iterative
be
process.
it might be an environment issue too. The fact that I'm not really running into them is interesting.
Hmm.
Um, anyway. There's a lot
Okay.
of moving parts in these systems. Like I've got the compiler, I've got all these different things that I got to try to, and then it funnels up from root vector. So anyway, a lot of moving
Well,
parts.
I can appreciate it. I mean, there's so much of it and there is so little of you, but I feel awkward sending these bug reports, but it's
No, 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 I appreciate it. Those bug reports help. No, no, never feel awkward about that. That like the bug reports make the thing better.
keep you on your toes.
Yeah, yeah, there's no worry there.
Okay.
Yeah, I added my graphic to jazz up the landing page a little bit here. So now we got my Cloudflow graphic on here. Lots and lots of stuff in here. I don't hurt for functionality.
Rube, if Cloudflow takes care of so many aspects of building things, is it strictly working well with Cloud Code, or it would work with any
Open code
any
I
other?
format.
You could use it for anything. I made Cloudflow v3 more agnostic. Now it's optimized to use Claude. Like it's still prefers, and I think Claude is a requirement in the package. If you don't care about Claude, then Agentic Flow is completely independent of Claude. So this is the core. This is what Peter was talking about a minute ago. This package here basically is the core of the system. Um, so a lot of the capabilities you're seeing bubble up from here, and then the actual like AI, if you will, is root vector. And I compiled all my Rust as WASMs, and then I use the WASMs or the NAPI RS. So bottom of the stack is root vector. Um, Middle, and then the package that makes it all kind of come together is Agentic Flow or Agent DB. Oh, what did I call it? Wrong button. Agent DB, not Agentic. I should have called it Agentic. I call everything Agentic. Agent DB. And no, wrong site. Agent DB. That's the website. What's Agent DB is part of Agentic. I don't remember where I put my stuff. Agentic Flow has a package. Agent DB is part of it. Where the heck is it? It's in here somewhere. Probably in my NPMs or something. Too many. I gotta clean up this repo. Agent DB. Yeah, here it is. Packages. Yep, that's how I put it all together. The modular approach works really well. Means I break something, and not everything else breaks in the process. It's a much better structure.
And the cleanup of the description is so much help with now when I point Claude Code or ChatGPT at those repos, they actually understand what's what. So that's a major step forward.
Well, the Cloudflow in particular, I've completely reorganized the main README, and so it's able to decipher much better. Like, and I'm that's why I included the sort of comparisons and the functionality. It's not all hidden in wikis and stuff. There's a lot of stuff there, but it seems to work better. And a lot of the indexers like ChatGPT and the Common Crawl and whatever, they only really look at the main README of the repo. So I gotta kind of say everything it does. So in 6 months, when ChatGPT and Claude have indexed the content, they'll just inherently know how my system works. And that's actually kind of the cool part now because it's been around for a while. All the major systems are now familiar with my code. So I can literally ask any of the systems about my code and it kind of knows how my code works, which is really propelled my ability to build with my own stuff.
Roof, maybe because of that, it's changing by the day. Maybe add there like it's changing every day. You should check this file for the
It
latest
is
update.
changing. It is changing every day. Yeah, the late my I created, I create so much stuff. It's hard to keep track of it all. Oh, I see Dury. How's it going, Dury? Dury's our agentic designer extraordinaire. And Nick, I missed our call this morning. Sorry about that. If you're
That's all right. We just went like full Rodman on that one instead. So
okay, yeah, I was up late and slept in. Sorry about that.
so was
I
I.
usually
I was mad scientist last night, bro.
yeah. I also go mad scientist.
Yeah.
Oh, you're on fire, Nick. There's a whole bunch of drops I keep seeing from you.
Yeah,
Gonna dive in.
I'm dropping stuff that I made around like 3 months ago. That's what
Okay.
I'm doing right now. But I wanted to you know, work on some of the later parts of it before starting to drop it. So anyway, I haven't tested all of it, so I'm sure a lot of it doesn't work yet, but it's at least in a certain level where people could take it and take it the rest of the way there.
Mm-hmm. And Rube, so you know we got Scott Silverstein, Ryan Smith today,
Okay,
and
awesome.
then
Let me
I
try.
heard a little something about Vermont. We may want
We
to
would do
touch on.
do you have the link to that somewhere?
I do. 1 second.
Yeah, so can you pop that somewhere
Yeah.
and I know it's not quite ready, but whatever. There's a group, we should have invited them to the call today. Mark and Mac, that are organizing a sort of agentic weekend at their hotel in a ski lodge in Vermont. So that's if we're gonna talk about that a little bit today.
Killington, no less. One of
I
the
want
best hills.
I wanted to ask you too, Ruben. There's a AI coding summit in late February. So they're looking for speakers on agentics. Obviously, I wanted to ask you first, and if you could manage to fit it in, then
Where where
you
where is it?
it's here. It's here. In the city somewhere downtown. So I wanted to obviously run it by you first, and then if you're not available, then maybe I'll jump in or Brad will jump in or something like that. But
And
yeah,
so it's like a rant. Like, are we gonna like actually code some stuff? Like,
I don't think so. I think it's just speakers and don't think it's a hackathon.
well, everything I do is a hackathon. They show, oh,
Yeah,
you get
you
10
got 10
minutes.
minutes. You
All
start.
right. What can we build in 10 minutes that'll blow your mind?
20,000
No
lines of
way.
code.
Yeah, there's this like I get on these calls and then there's always like the guy that really appreciates what I'm doing and is like drinking my Kool-Aid, and then there's like the
Yeah.
tech guy, and the tech guy's like, nah, this guy's a vibe coding moron, right? Or whatever, old tech guys, they're crotchety, and then I'm like, okay, here's what I'm doing, here's what I'm building. Have you ever heard of Rust? I'm like, and then by the end of the call, they're like, my mind blown kind of situation. That's I live for that moment. That progression from fraud to like whatever the opposite of fraud is.
Yeah.
I know I'm not a fraud, but I gotta prove it. Fun times.
There we go.
Oh,
I see
just a minute.
Craftsman. Good to see you, Craftsman.
I can customize this.
Hey, Robert.
How are you?
Oh.
I'm cooking barely. I've got been working on some interesting stuff. Yeah.
Nice. You gonna get a chance to meet up with Reuven there in Bangalore?
Yep. I started booking my tickets to Bangalore. So yep, looking forward to it.
It's yeah, can't be as bad as the last second business class from Canada.
Oh,
He's still not paying
that's
for
gonna
it.
be expensive.
Yeah, $20,000 is what that ticket costs.
Whew.
That is the most expensive ticket I think uh I've ever had to purchase.
Sounds like a ticket to the moon and back.
Well, that's like I think that's more than 20 grand, but it
What
should
is
be
20 grand?
You own a
20
part of the
grand.
airline now.
What's that?
So you own a part of the airline now.
I don't
Yeah,
know.
that's what I
It's
think.
well, when I have to travel any more than a couple hours, I tell them I need business class or I'm not going. And they accept that, so good enough for me.
I
It
mean, it's a
looks like
long flight from
Well,
Canada to Bangalore across the Pacific.
yeah, well, I actually have to go. I'm going through Munich. I couldn't go through Dubai, some visa issues there. So now I gotta fly through Munich and then fly on to Bangalore.
And then back to Canada or back to Munich?
Might go to Singapore and then back to. So I might do an entire loop around the planet.
Wow.
Nice. You get a chance to meet
Yeah,
Robert Yee in Singapore?
yeah, exactly. The whole crew there, they're eager
Fantastic.
to. Yeah, it's like, oh, you can just stop by Singapore. It's like an 8 hour flight.
Yeah,
I don't know
yeah.
if that I
Hop
don't know if
in.
that's yeah, let's just stop in on an extra 8 hours. Then I gotta fly all the way over the North Pole back to Canada. I've
Yeah.
actually done the entire circumference of the planet, and that's a 4 day trip.
wow.
Whoa.
Yeah.
Yeah,
Yeah.
so I leave on Monday and I'm back on Friday.
It looks like Reuven, it is actually online. I just looked at the site again because I got a lot of balls in the air, but it looks like it's online and it does look like it's like an AI code, AI assisted software development and AI engineering. So looks like looks like you would
Let's
be building and I'll share the link.
Yeah, I'll do it, but my only condition is we have to be able to do some live coding. I don't want
Okay.
to I don't want I don't want to do a PowerPoint presentation. That's boring.
Yeah. I'll set it up and see what they have to say.
What we like hyperspeed hacking. Like what can you
Yeah.
build in 15 minutes?
Yeah. Okay.
Yeah.
I'll let them know.
All right, near the top of the hour here. And this has been broadcasting too, because it was auto broadcast now for some reason, just this particular Zoom. So I don't know why.
Yeah. Previous Friday was.
Yeah, there's no. All right, I'm hitting record because I like to start on time. Record to the cloud. All right, I got set up. Thanks everyone. What's the date today? The 23rd. It's this week has been a little more the little eccentric in terms of the stuff that I put out there, but it's yet another crazy week in AI. Apparently, there's a storm coming to Toronto this weekend. January in Canada is not unless you like cold blizzards, it's not the nicest time to be in Canada, but it's nice from my office here. Rob, it's probably even colder where you are.
Yeah, we're currently at 25 below zero, and then
That's
it's
Celsius.
going
That's
Celsius, yeah.
Celsius. I,
And
I, I
then
think I think Fahrenheit and Celsius converge at what, like minus 28?
yeah, something like that, right around there. And yeah, and then it's going to minus 34th of wind chill by tomorrow. So it's really cold. Thankfully, I don't think we're expecting snow over the next 2 days up here. So we should miss that part. So you'll be out there with the snowblower, but not me.
Well, I've got teenage sons, so
Yeah, that's right.
now I just pointed at the front and tell them to go do their thing, and they go. So yeah, it's the best thing ever.
Yeah, yeah,
But yeah, it's winter. It is
Yeah.
what it is.
I
yep.
got
Slow
minus
fashion way.
29, if that feels reassuring. That's with the wind chill, I should say.
Yeah,
Yeah.
I'm sure Martin, you've probably built a robot or something that'll like plow your driveway or something.
I've
Early
certainly
adopter.
been amongst people who have. I can't say I have, but yeah.
Yeah.
Oh, and you're wearing your Rotman sweater.
Oh yeah. I had a meeting this morning, so I thought I'd show up.
Okay, yeah. Well, that's me. That's why I know Nick and the crew from our I don't know what we even call what we're doing with Rotman, but I work with Rotman. So yeah, cool.
Yeah,
Nice
speculating
to
stuff.
see that a little promotion there. Rob, who do we get lined up today?
We got a bunch. So, first of all, big congratulations to Bill McGraw and David Grattan. They had their kickoff event in Vancouver, their first meetup of the Vancouver chapter. So it was really cool. It was a good turnout there. And then for today, we have Scott Silverstein, one of the longtime members, and then Ryan Smith is going to give us a talk. He has a skill aggregation tool which is really neat. I got a chance to take a quick preview of, and I love this angle and sort of the immersion of prepackaged skills in all kinds of little pockets of specialty tasks. So he's going to walk us through that. That should be really interesting. Just a bit of a flash forward. Also, Toronto Tech Week is back again. That's coming up. It's not until May, the 25th and the 29th. But the promotions and getting ready for the event, that's all starting over the next week and a half. So I know the marketing team has a lot on their plate going on right now. If there's other volunteers that want to help with the marketing team's work, they've got their fingers in a lot of pies. There's a bunch of stuff that's coming up around Toronto Tech Week and some additional work on the website. And then I've heard something about Killington Roof.
Killington, yeah, and they sent me. It's so
Vermont.
we're attempting to create a retreat. Let's see here. What it's they sent me a link. Can I show it? Download, just share it. I can publish. Copy and publish link. All right, yeah, it's built as an artifact currently, so the site isn't live. Just FYI. But I can sneak peek it. All right, so yeah, they sent me this. They actually built this in Claude, and so this is just what it looks like. But I just published it quick, and let's see what the actual link looks like. Looks like this apparently. So Mark and Mac and the crew, I don't know if they're on the call, feel free to pipe in here. I'm probably gonna butcher their story. But what they're looking to do is a kind of ski weekend in Vermont. So they've got a small hotel that they have in Killington, Vermont. Oh, am I sharing the right screen? I have shared the wrong screen.
Yeah, you're sharing the right screen. That's right. We just
Oh.
need a mute here.
Oh, okay. So essentially, what we're doing is we're going to hang out and do 3 days of hacking, building, skiing, maybe some drinking if you're into that, and in Vermont, which they tell me is the most liberal state in the United States, whatever that means. So I think they're trying to tell me it's a friendly place to visit. So that's good news. So we're this site. It's a work in progress. Just FYI. And so yeah, so we're gonna build stuff together. We're gonna get to know each other a little bit, and we're gonna hit the slopes. I'm a skier. My boys are snowboarders, and we'll do a little bit of that. Apparently, this is the best. Apparently, the best ski hill in New England,
It
according to
is.
them. Yeah. So he's got a 3,000 foot vertical drop. That's cool. So it's unlike Ontario skiing where takes you 20 minutes to get up the hill and 30 seconds to get down it. It might be a little more interesting.
155 trails too. It's enormous. It's absolutely beautiful.
The pricing, I have had no involvement in this. That'll be a question. We'll get Mark and Mac on the call next week. But what we aren't doing, this isn't a for-profit endeavor. The money, if there's anything left over, is going towards the foundation, and maybe some of my gas to get there. But that's about it. We aren't doing this to make money. I don't know if these are the final numbers or not, but that's what they said.
But the important thing here, from what I can see, that Queen Suite. So if anybody wants to double up in a room, that means it's about $1,600. And that's all inclusive with all of the meals for 3 days, 3 nights. So that includes breakfast, lunch, dinner, snacks, et cetera, et cetera. Not the ski lifts. Got to pick up the ski lift if you're going to get some skiing, a little bit of skiing in. But that's a really good deal to be done there. That's really good.
Yeah. And the idea is we're gonna build some things together and learn and I don't know, get to know each other. Maybe we'll invent a agentic drink or something that we can partake in that weekend too. I don't know. Apparently there's other places around. We'll get this website up and running. I think it needs, this is built, it would appear to be built in Claude, so somewhere it needs to be hosted. But this is the general idea of what we're trying to do. So if you're in and around, so I think from at least from my area here in Oakville, just outside of Toronto, it's about a 7-hour drive. So I can drive down and through New York and into Vermont. Um, but if you're on the East Coast, it's probably not that hard to get to.
And
Otherwise,
they can accommodate, I think, up to 60 of us.
yeah.
So that'd be a pretty epic retreat.
So what I want before I blast it out to the list and whatnot, I was gonna basically share it with you guys here. Because the site's not live, I'm not sure exactly what to tell you about how we actually register. So maybe should we create like a WhatsApp channel or no? Actually, we've got our Discord. Maybe we just create a little. We use the event Discord and I'll post it there first.
Sure. We'll tie it
Martin,
into the website and folks can go through and register right through the website.
Yeah, I'll find out exactly what's going on with the pricing as well. Again, I don't have a good answers for you guys on that. Probably should be more intimately involved there, and get a final on what the actual end prices are. But yeah, it'd be fun to hang out. We got a nice crew of folks that are interested in doing this. And if this works out, what I'd like to do is something similar in the summer, maybe in the cottage country of Ontario, just on the Great Lakes. Maybe we get something. Maybe we can get like one of those giant, Muskoka mansions and take that over for a weekend or something.
Yeah, I think Martin was going to host, right?
Martin, you've got a giant mansion
in the Muskokas?
No. we do have a cottage on one of the lakes, but it's not that big.
Yeah, I got one too. It can't fit 60 people, but it'd be fun to do that in the summer as well.
Sure.
So maybe we do a winter, and this is like, again, this is not meant to be like the Linux Foundation, type of event. This is meant to be, for us to get to know each other, build together, hang out, that kind of thing. A little more casual, I think, than going to a conference. That's the idea. All right. Before I jump in, I saw that Barry mentioned you're thinking about doing one in a meetup in Seattle. That'd be cool. We've got tons of folks in Seattle, lots of big tech companies there. So
I'm getting a place up on South Lake Union, so all the tech guys of Seattle area, Puget Sound, Bellevue, just drop me a line.
I can probably help, given how many people I know using our tools in that region right now. So, and by the way, did you see that poster? I think there's been a couple articles that came out in the last day or so saying basically Microsoft's like crazy adopting Claude and how they don't even use their own tools or whatever. You can't blame them for using the best tool available to get the job done. But it does sort of show how quickly Claude is growing. I also saw another stat said fastest growth trajectory of any tech product ever. They just hit a $12 billion a year annual recurring revenue, and they launched it in May. So they went from zero on that particular product to $12.5 billion in,
Wow.
I guess that's what, 7.5, I guess that's 7 or 8 months, something like that. So that's substantial. I'm kind of drafting on their coattails a little bit with Claude Flow, but you can definitely tell that the space is super hot. So yeah, interesting to see that happening. yeah, in terms of what we're going to do today, I'll give you a quick overview of some of the latest crazy, and then we'll jump into Ryan and Scott and a few others. If you are interested in presenting or have something to show, feel free. Before I do though, Martin, you have any updates? I saw you share a couple links quickly to the community.
Yeah, sure. So I guess the main thing is we do have this video, submit a question, give us some feedback, be a guest, and even I was saying to Rob, we can use it for people to help suggest that they want to be an ambassador. So yeah, you just go to the CB radio section on the main website, just leave us a little video, and we'll get back to you. I'm sure at some point we will build this agentically ourselves, but I know several members of our community have had success using that tool. It's pretty neat. So
Yeah. I kind of like the idea. I think the CB radio, it's kind of has the right sort of retro vibe that we're going for here. And thanks Martin and Matt and the whole crew who put this together. Looks really good. And Dory, of course, who makes us look beautiful.
That's
Yeah,
right.
this is awesome. Yeah, then for those who don't know, Dury's on the call today, so shout out to Dury. She's our agentic designer. So if you're looking for design services, she should be your go-to. All right. So, one of the things I hear a lot of lately, I think people have finally put together the Agentics Foundation and my fixation with Isaac Asimov. So it's pretty clearly, if you've ever read any of his books, you'll see the influence in a lot of the stuff I've done. So in that vein, I'm like, all right, what can I do with the prime radiant, which is this concept within the idea of the foundation, both the book and the TV show. I think it's on Apple or something like that. And essentially, the idea of this thing is essentially that it helps predict the future based on the sort of structure of things, right? So in this case, what I was looking at, and this is actually what came out of yesterday's vibe coding session, is this idea that a lot of people are showing up and saying, "Tell me about the sort of your confidence, the AI that is the LLM. Tell me, are you confident in what you're telling me?" And asking the LLM to give you a confidence score or confidence rating is kind of insane, right? You're asking the system that basically makes stuff up and gives you the most probabilistic answer and then says, "Are you confident in that answer? Give me a score." Now, of course it's confident in that answer. That's why it gave you the answer. But that doesn't make the answer true. It just makes it probabilistically, relevant. Right. So anyone that's going and saying, here's a prompt, send it to the LLM, and then give me some kind of diagnosis, of it it's inherently flawed from that point of view. So what I'm doing is I'm saying, what if I could use a mathematical structure to actually allow you to separate that sort of the concepts of confidence and contradiction using a kind of mathematical underlying formula, if you will. So then I can infuse that directly into the LLM itself. So when it comes to things that involve, defining the sort of grounding of information, is it true? Is it real? Now I've got the ability to sort of have a structure based on this idea of an energy. Now, in terms of confidence, traditional, yes, I'm 85% confidence. But what I really want to know is there any contradiction in the thing that I'm asking you? That's really what I'm asking. And then, so rather than being kind of confidently wrong, I'm 100% sure that's true when it's 100% wrong and doesn't know that it's wrong. It knows now when it doesn't know. And that's a fundamental problem of a language model. It doesn't know when it doesn't know and just assumes that the most probabilistic response is the right thing. It has no way to say, stop for a minute, is that actually the right thing? Even when you use reasoning structures, when you ground it with sort of RAG style injection of data, it still doesn't really inherently know. So now what I'm doing is it provides a kind of consistency. Now, a couple things to note what it isn't. It's not a probabilistic score. That's what an LLM is. Score this thing, give me an itemized list of the best to the worst. That's a probabilistic score, which works for lots of things. Don't get me wrong. You can ask ChatGPT to give you a list of the top 10 things that you should do next. But for a lot of things, it doesn't work particularly well. Back to the prime radiant for a second. What it doesn't do well is adjust to the sort of pressure that reality places on simulations. So if I'm trying to, let's say I have the objective to do something and I need a guide to get me to that particular objective. Now I'm going to create a simulation. I'm going to create millions of variables and millions of alternative realities to get to tell me what the optimal sort of path to that thing is. Now that's going to set forth a series of actions that says, you are going to become this thing. Now, how do I become that thing? Well, here's a guide, here's a map, here's a process you can follow. As you follow that, different realities present themselves. Different choices are made. Competitors will adjust. I mean, things will pop up. Now, the system is capable of taking all those sort of ideas and then understanding the inflections of those sort of potentials and combine those with what's actually happening, which again, a language model doesn't do really well. It's a predetermined set of information. I've given it all the information on the internet and said, give me the most probabilistic answer to all the information on the internet. It's not adjusting, it's not adapting, it's not learning, it's not changing itself and its nature as it sort of progresses along our reality. That's what this is trying to do. So a whole bunch of crazy math, but the most important math is using is this. I'm not even going to try to pronounce it, which is essentially a framework for measuring consistency across interconnected data. Now, when you look at what's happening under the covers of my system, you've got this idea of latent space, you've got the vectors, you've got the graph, and all the sort of interconnected relationships of all that information using a hypergraph. So there's multiple edges, multiple points of intersection, and then that is translated into math, right? The vector style math, which you see here represented as an embedding. So in this example, you see node A meeting at 3 p.m. All right, node B meeting at 4 p.m. Right, slight variances, right, in the vector, right? You see here you've got 0.9 in the location, 0.1, and you get 0.9 and point. So they're essentially they're adjacent to each other, but they're slightly different. Now, that is an important distinction here. Now we're seeing here that there is a kind of there's an inverse component to those two items that the system can understand that it's not quite right. Well, in this case, it means that the meeting aren't aligned. It's one saying 3 and other saying 4. So therefore, we have a problem. The identity map should match, right? And that's a really simple example. This can be done way more complicated. So you can do this on things like DNA, where you correlate two people's DNA to try to figure out, why one person is more susceptible to a certain disease than another. You can do that based on pattern matching, where you're learning those patterns on fly, a stock or your brain or whatever it happens to be. So that provides the ability to, have a kind of baseline of arithmetic that allows for the understanding of contradiction of the system itself without having to describe it in a way that is linguistically bound. Meaning, I don't have to describe my problem in English to understand that there's a problem between the fact that there's, one person wants something at 3 and the other wants something at 4. So it's bounded based on math. Now, the math that underpins it is based on this coherent field of energy. Again, and okay, just to step back for a moment. You saw, Jan LeCun came out with his new AGI or whatever, and he's taken also an energy approach, but his energy approach is the other end of the spectrum. His energy approach assumes a completely bounded world that are with known sort of restrictions. I'm assuming that the system has no inherent restrictions. It's much like our own universe, and it creates, entropy, chaos, and change. And I need to evolve and adapt to a world that is unknown, where he's saying, I'm giving you a very particular set of problems, and I can do those problems almost instantaneously. But anything beyond the scope of those problems requires a retraining of the system. My system is saying every step, every move, every decision, everything that happens is just another incremental point of learning as the system evolves alongside you and the problems you have. So it uses this idea of a kind of compute ladder. Now, the compute ladder actually looks and mimics a lot of the same sort of human processes you would have in your body, like the idea of reflex. I just, someone throws a ball at me and I notice that I jump, or a jump scare in a movie. It's a reflex. It's inherent. It's a heliostatic kind of component. My heart just beats. Now, that happens really fast, right? I need to be able to adapt really fast. Then I need to be able to get the information and then understand and correlate that information as the information exists within the structure of the vector and the graph and the interplay between the two. And then depending on that, I can make decisions. I can make a quick decision, like this is something easy, or I can do something that requires more in-depth analysis. At which point the system's capable of saying, okay, I don't have that capability, but I know because I've been trained that that capability is something I can go get from a tool, an MCP, an API, another model, another system, another WASM, another something that's adjacent to it, or the highest order of model available to the system, something that means it could potentially cause breakage, something that's irreversible, something that causes major problems. It can be then offset to a human. The human in this particular model is the highest order model. I'm treating a human as a high latency AI model. I don't make a distinction in this case between a human being something other than just another model available to the core, but it just happens to be a model that takes days or weeks to respond. So it's back to that idea of eventual consistency. I don't care if it takes 1 nanosecond or 2 weeks in this particular scenario. Um, so it opens up tons of options for sort of this idea of witness records. So if you observe it, does the observation of something become the actual sort of expression of reality itself? This acts as a mechanism to actually understand, witness, record, cryptographically verify, and understand each step along the way to get to that outcome. Where traditional language models like throw GPU at it, ask a billion questions, and here's the most probable answer. But don't ask me how I got to that probable answer. It just kind of is magic. This is inverse to that. This is like I don't need to ask a billion questions. I need to get to the right answer as quickly as possible and understand whether or not there's coherence in that particular answer. Does it make sense? Is it logical? Structurally logical? And if it isn't, then we need to come up with a new way of thinking about it. And that just happens, which is kind of cool. And it plays really well in this whole idea of the sort of world of Isaac Asimov and whatnot. So, and this is really, really fast. Again, microsecond sort of performance. I've optimized this also using if you're on the Intel. If you're playing on Intel, you got to look at AVX 512. It's their, I'm not going to get into the real details of this thing, but it's their optimizer for the CPU. And for the types of things I'm doing, there is no better system currently in the market to do this kind of vector style intelligence. It's just incredibly fast. Now, if you're on a Mac, they've got a similar one called Neon. I think that's at like two. I don't know the exact number. I think it's similar to the AVX2 that exists in other models. And I was able to do GPU stuff, so you can, if you want to go GPU, it's a fun little thing. I know it's a little out there, but that's our Thursday vibe coding sessions that what we like doing. What else kind of else? Oh, shout out to Steve and his blog. I kind of like the fact that there's some other people doing this. It gives me a sort of secondary validation and verification that we're not crazy after all. For those who haven't tried Gastown, it's interesting. It's rudimentary. I think it feels kind of like, and I'm nothing against Steve, like great guy. It feels like what we were doing like a year ago, but I think he's earlier in the evolution of agentics than we are, but he's definitely heading down the right path. He's a really good post here on sort of exploring what he's doing, why he's doing it. So we're worth taking a look. He's mentioned he's got a nice call out to Claude Flow in here. Where did he put that?
Can you give a 30-second summary of what is Gastown? Because it seems like the term was overloaded. I searched for it and got multiple conflicting answers.
It's essentially an agent management system at the most simple term that uses skills. He's got this kind of level. I have my pact sort of idea where I've applied different concepts to sort of autonomous coding. He's using a similar sort of concept. Um, he describes it here. Agent orchestrators are programs that use agents to run other agents. In the most simple terms, yes, it's a series of agents. So he's outlined Loom, Cloudflow, and Gastown. And he's saying that he's thinking about how he does it. It's worth a read. He's much more verbose in his description. Cloudflow is a bit different. It tries to be a factory. It's clever, but it's not thinking about the problem the way he is. I think I am thinking about the problem the way he is. I'm just much more broad in saying there's more than one way to solve the problem. So my system is kind of composable in the sense that if you want to use it like Gastown, or you want to use it as a skill orchestrator, or you want to use it in something that's completely reinvented and I never even thought of doing, you can mix and match the various parts, the various hooks, the various MCPs into different configurations and different deployment patterns. So when you install it for the first time, you're getting my preferred architecture, my preferred way of building, but it's not the only way to use it. It's just my way that I use it. Now, if you want to change it up and say, well, I don't really like the way you do it, I want to invent my own way, I want to include some of the Prime to Radiant stuff, for example, then it's a matter of pointing it at Prime Radiant and saying, can you create me a coherence layer? And suddenly the system will start acting as a coherence layer with anti-drift and anti-hallucination properties. So all those things exist, but you have to discover them. And in some ways, what he's describing here is the fact that he hasn't discovered that yet. Not that it's wrong. I think what he's describing is actually true. It's just very sort of, it's preliminary. It's like the first time you look at something, you're like, oh, that's how it works. But then I got to use it for a while to really figure out how it actually truly works. And he's got a lot of analogies. He's got these Gastown patrols. He's kind of gamified it a little bit. I went less gamey and more like practical. Maybe I should have went gamey. I don't know. But it's worth reading. It's kind of cool. And I maybe I'll integrate Gastown just for the hell of it. I got the plugin system, you know.
Hey, Roof, I looked at Gastown a little bit. So what I found about it that Cloudflow doesn't have, you can have multiple independent projects basically with their own life cycle, and they kind of talk to each other. Like if something needs to be done, like it just kind of sends it to another swarm and say, hey, like would be nice to do that. And then just abandons it, and later on they get the message say, hey, we implemented that. But it's independently operated.
I've got that concept as well. So
You
that
do?
uses that uses my so I've got foreground and background workers. The background workers will operate independently of Claude code at all. It uses the root vector system, and it can also invoke resources that sit external to the environment if you want. So if you want to spin up, let's say, a Cloud Run instance or CloudFormation instance on AWS, and you want sort of more compute power or a larger computing environment, I needed 10,000 agents for 5 minutes kind of thing. It can then go and do that independently, then reports back. So I've got an internal messaging system that provides both foreground and background communication channels. The background communication channels is actually probably the more interesting communication channel. The swarms can actually collaborate independently of what you see in Claude, sending sort of guidance saying, I need more resources here, go do that, go do the other thing. Now, again, my primary problem is exactly what Vlad, you just mentioned. It does so much crazy stuff. It's like hard to say, it's hard to describe a multitude of different ways that thing could be used. So people are just like, well, it doesn't do that. Well, it kind of does everything. And like, but then the question is, well, if you do everything, what are you good at? And so back to, I need to position it some way. I can't say I do everything for everyone and nothing in particular. That's not gonna, who's gonna buy that? So I'm like, okay, here's my general approach, and that's what you're getting out of the box.
Right. But can you have two independent swarms? They kind of like have their own like sort of focus. So for example, one works on like the product catalog and another one works on like recommendations. but they work independently with their own queens, and sometimes
Yes.
they need to have very thin channel. They don't need to see like all like communication between all these internal agents, but they need to send like very like short messages, say, hey, we want this feature to be implemented to the other swarm, and basically abandon it. And when the other swarm decides to, hey, like we're gonna like consider this feature, and they will do it and send it to the first swarm. Like, so it's like a thin, sort of
Yes.
like a
So
narrow channel between the independent swarms. Like,
yeah, and I'm not using I can use decentralization. That's another option, but what I'm actually generally using is a shared Postgre database. And the Postgre essentially infuses all the sort of learning and swarm coordinations directly in the database structure itself, right? So now let's say I have 3 different projects and they're similar. Maybe they're in my case, I'm using RuVector as the bottom, I'm using Agentic Flow at the middle, and Cloudflow at the top. Now, all those things which kind of need to be aware of the other. Now I can give it that sort of Hive awareness or structural awareness directly in the shared Postgre database that you'll see here. Now that's just like a Docker instance or whatever. Then you've got the background workers. The background workers are capable of understanding both what's happening in the individual repo itself, but everything else it's related to it. It can audit, it can consolidate, it can optimize, and those things are always running. There's a daemon that basically runs all the time, figuring itself out, finding coherence, asking is it true, is it valid, is there drift. So the next part, and again, look how much crap I've gotten here. That's the problem. Then there's a drift system. The drift system basically allows the system to understand, is it still on no, this is my embeddings. Let's fine. Let's again, too much stuff here, but essentially the drift system will help it determine if it's doing what it needs to do. And then ultimately at the end, is it secure? So it looks at prompt injections. The problem with distributed and potentially centralized swarms is the level of autonomy opens it up for various forms of attack, right? So if you give it true autonomy and true multi-environment access, all of a sudden, a random website it visits can do a prompt injection, and suddenly your entire swarm has been compromised. So in this scenario, you've got the defense system that looks for, it's always running, always trying to mitigate the sort of ability for it to be exploited. So there's just all these moving parts, and that's my problem. Too much, right? Too much stuff.
I actually like spent almost a week. I stole stuff from the Cloudflow 3, and also from Dragon's Agentic UI. Like, you guys both have like super great ideas, but I kind of like plug the pieces, and like I'm still putting my own thing together.
Yeah, I saw Dragon, by the way. I saw your post earlier today. That was spectacular.
Yeah,
I
we
love.
trees, but building using your Lego building blocks. So
Yeah, I kind
using
of
the approach,
yeah, I'm stealing from both of you. Like, and it's
It's
like.
not stealing. It's not stealing if you give it away.
Yeah,
That's
which is actually,
why.
maybe we'll have conversation later, because I was just thinking recently about what's the intellectual property on the prompts, because right now people like used to be source code. So for binary code, people were just giving it away because like it's like so complex and cryptic, nobody would bother, like only like very dedicated people would bother like digging into binary code. So source code was people were kind of protecting. Now like all the like agents can just put out tons of source code of high quality that nobody would in the right mind would actually look at the whole thing and try to understand it. But the whole smartness now is in the prompts, and I heard the new term, it's called like the agentic harness. That's what the Cloudflow is. Like, it's basically, it's not free roaming agents, but it's providing harness and infrastructure to them.
I like the harness concept.
Yeah, so
So
what's the
we're running a little low
intellectual
on time.
property on that? I mean, you're giving everything away, yeah, but
yeah. Just a quick moment. We're gonna jump to Scott and Ryan here in a moment, but one of the things that I'm doing, and I'm gonna be honest with you guys, is I'm putting out all these just absolutely insane, crazy, cutting edge things as a hedge against those who are going to patent all these things at some point in the future. Everything I've put out is no longer patentable. 100%. So I've put out, I don't know, I don't even know how many millions of lines of code, some infinitely crazy amount of code. That means some random company is inevitably going to figure out that the approach is that I'm taking, maybe one of them, maybe all of them, is something that's valuable to getting and achieving their things. The first thing they're going to do is they're going to search the web and they're going to realize that I created that 6 months ago, right? Therefore, prior art, no patent. And you look at all the crazy stuff I put out, especially in the Rue vector, that's literally several thousand different patents that now cannot be filed. That means I'm protecting us, I'm protecting our industry, and maybe I could have sold it for billions, but I don't care. I don't need to be a billionaire.
Is
All
there
right, we
yeah,
need
okay,
to jump,
yeah.
guys. We need to jump. We need to jump. Robert, who do we got up next?
We got Scott, and hey Scott, how are you doing? And then we'll open up to Ryan. Hey Scott, you're on mute there, my friend. How are you? Welcome. Good to
Hey
see
Robert, how's it going? Good to see you.
you. Wonderful.
All
We've
right.
got we can open up the screen share for you there.
Cool. Share. You said all right?
Network topologies, yes.
Cool. All right, I just wanted to cover, I've been looking into agentic network topologies and how organizing our agents and how they communicate affects throughput, latency, and the queues that they'll face. So diving into it, we have 6 kind of basic network topologies that you'll usually see. We have the star topology, usually with an orchestrator in the middle, the mesh topology where each node is an agent and they're fully connected to each other. Ring topology, where each agent is connected to the next one in a ring. The chain, which is kind of like a ring, but does not complete or go around. The leaf and spine, where you have these 2 nodes that connect the rest of them, so you can have good east and west traffic. You'll see this in like data centers. And this fat tree hierarchy, which kind of looks like a corporate organization. It's kind of similar to leaf and spine, but has more layers to it and some hierarchical qualities. So jumping to some experiment,
Scott, so just as a quick, you skipped my my architecture, the hierarchical mesh.
I'm sorry, I haven't dived into enough to feel comfortable presenting it.
Okay,
But I did want
no
to
worries.
note,
We'll zoom. We'll get back to that.
cool. I wanted to note that you take a really interesting approach to this in Root Vector. I'm sure you'll talk about how you optimize your networks. So for experiment, I wanted to look at our different workflows that we'll usually see in agentic, so swarm, an orchestrator, RAG, and debating. And we wanted to test them across these different topologies. So I had anti-gravity set up 432 different scenarios, go through them, just sweep over the different topologies and the different workflows. And with different speeds of computation and message queues and sizes of data to process. Let's look at our throughput. For Swarm, we could see that Mesh had a way higher throughput than anything else. However, variance was pretty high. And this makes sense. Swarms are gossip networks, and being able to talk to other nodes in the system with one hop is hugely beneficial here. We can see that star, where you have that orchestrator in the middle, everything has to go through that bottleneck. So if that queue starts loading up and it can't process it fast enough, the system breaks down. For orchestrator, you can see that we got high scores kind of across everything. And the key thing to note here is that a mesh can look like a ring, or it can look like a star. It can also look like a ring. And in the case of a mesh, stars are pretty fast and aren't invariant, and a mesh can look like a star and send things to the orchestrator and have similar throughputs. because those wires don't matter, you might want to limit your system down and make it into one of these smaller networks. So you're not spending either money on actual physical connections if you're doing it a physical network or virtual connections. For ag pipelines, we saw that mesh was very fast for this. Star got clogged up. In virtual networks, where connections are very cheap, you can use a mesh. But if you're in a physical network, this mesh gets very expensive because it's an n squared connection amount. So a lot of times, like in data centers, they'll use the leaf and spine. And then in debate, we saw that mesh, ring, and chain all had similar throughputs. Star, leaf and spine, and fat tree all ran into issues. The mesh works here, but you're connected way more than you really need to be. So there's limitations in my experiments. For the fat tree, a few of those agents are used as switches, so you're not doing as much processing. So that was why that one was a little bit lower. And in reality, wires are not free. A lot of connections can add up really quickly. And then in mixed workloads, leaf spine is pretty good. That's why a lot of data centers will use it. And that's pretty much it. Topology is definitely worth considering when you're developing these systems. Any questions?
A couple things to note. I need to say this is great overview, and I think your results are very similar to my results. So that is independent verification for sure, and thank you for doing that. There's a topology that I've been using mostly for Claude Code recently, and it's kind of hybrid, but it's what I call a hierarchical mesh. In a hierarchical mesh, what I
Yeah.
have is I've got the queen, but the queen sits dormant most of the time. So within the mesh, like when the various agents and sort of components are either working or completed, they then may report back to the queen occasionally for guidance. And that's like the bee heading back to
Okay.
the main, what yeah. So and at which point it might say, oh well, you forgot to do the security stuff, or there's a potential exploit, or you might need to optimize. I always have an optimization part, but the Claude system has
Yeah.
a tendency to forget to benchmark, optimize, and secure, no matter how much times you try to tell it. The hierarchical mesh allows it to, oh, you're not actually done. That combined with the ADR and
Interesting.
the DDD provides the anti-drift capabilities because the queen is kind of keeping it on track. So without the queen, the mesh has a tendency to kind of drift into other areas that are adjacent but not necessarily particularly useful for what I want to do. Now, I think
Interesting.
I saw that Guy had a question. You totally want to use different topologies depending on what you're doing. So what I just described is purely really good for like autonomous coding agents. But when you're looking at things like a sequential training, where you might want to have a kind of pre-training for like root vector, where I want to simulate the future and I want to give it like a core sort of starting point where it starts and then can learn. Then in that scenario, you might want to use something like a ring, or you might want to use a chain, or you might want to use even a star. But because it provides this sort of ability to train, verify, modify, improve, and that isn't a mesh sort of problem. That's a more
Yeah.
sequential problem. But I need to be able to do that in parallel. So where now, if I can do that in parallel, you can see the sort of hierarchical scaling option. You have number 6. I can then combine your fat tree that you're calling it with the ring. So, line 2 is a ring, line 3 is a mesh, line 4. So you're able to sort of mix and match topologies to optimize for the problem you have. Guy,
Yeah.
you got a comment?
Yeah. So this also is dramatically driven by the connectivity technology you use. Like if I'm doing direct sockets, I reach a scalability issue with things like mesh. But
Yeah.
if I'm using a pub sub broadcast kind of transport like ROS DDS, it allows these topologies to arise naturally without reaching scaling limits of sockets, right? So I can just register interest in something. Something to think about. Hold up.
Yeah, it's a good point. This is great. And what's your framework for testing it? How'd you build it?
Through anti-gravity, I think it's all Python.
Nice.
Then
Rod.
using Gemini and Claude.
Yeah, that's really interesting. I haven't been in networking for a long time. Do you guys see how much of this was built off of, some of the logic around, like ISIS, other traditional routing protocols, or do those break down, or is there anything that we could layer on top to optimize some of that decisioning? Or what's the background? Is there any background there on that?
You guys know my background is cloud computing and infrastructure as a service. Before I was the AI guy, that was my thing. And the essentially a lot of what we're doing is we're standing on the shoulders of giants. I'm not pretending that I invented all this stuff. I just reassembled all the concepts that existed over the last 75 years of computer science. And when you look at topologies in particular, most of those topologies have been well defined in the networking space. We're now applying those concepts to operate, things capable of reasoning, logic, and adaption, which is unique because in the previous iteration of networking and cloud computing, you define it, it would do it, and then it would be done. Or if it was operationalized, it was an RPA style. And as soon as it went beyond sort of the boundaries of what it needed to do and how it needed to do it, it would either fail or just not, or be ignored altogether. So all of a sudden, each one of those nodes that he's describing is now a neuron, and the lines in between those are synapses. It's the ability for the information to flow. The major breakthrough that we've had over the last couple months is now I can look at the inverse information that exists within the topology. I can look at everything that's in between and say, where's this going to break? How's the integrity holding together? And how does that relate to the overall operations of the system? I'm essentially discovered using MinCut and a few other tricks that it isn't the thing you're looking at that matters. It's everything else you're not looking at that matters and how those things fit together. And the topology allows us to just describe it in a sort of multidimensional vector mathematical structure and then understand it in really low latency. It's networking, right? It's like just adaptive networking at the most basic core with intelligence applied to it, attention applied to it. Vlad.
Yeah, I thought it was cool. Look at that guy.
Sorry. All right, we have no other questions. Scott, this is great.
Yeah, hey, can you hear me? Actually, yeah, I was on mute. Yeah, I just gonna make a comment. First of all, this is so great, and I'm spent a lot of time on this kind of world. And one thing I noticed, sometimes people start worrying about it before they even they worry about scale before they have a scale. Because as Scott suggested, when you start going into thousand, so in my opinion, so before you get to a few hundred nodes, that doesn't apply. You can just do the full mesh, and if you have robust underneath. When you start going towards the 1,000, you start basically experiencing the scalability problems, and you need to apply these techniques. When you get to 10,000, you definitely need to do something like that. But lots of people, they start thinking about the scale when they have 20 nodes, and that is they spend a lot of effort on solving the problem they would never have. So that's a little bit caution there.
Yeah.
I agree. I think I agree with Vlad to a point. Now, what you're describing is like production level scale, building applications, having long running processes, and what you've described is perfectly true. But the inverse is like when these things are ephemeral to a point of nanosecond, pictosecond, microsecond timescales, that level of scale is really important, right? I'm now trying to do, why is it zooming in on me here? But anyway, I'm trying to do that in these really tight constrained spaces, right? Within, so 1 million different processes that run for less than a microsecond kind of thing. That scale becomes meaningful because it's so tightly bound. But it's a different problem than trying to scale my website to 1 million users.
Yeah, but
I
when
saw
you're
you.
doing microseconds, so if you're designing the chip, that's when you need to care about it, right? So if it's
Yeah.
the, yeah.
Yeah, and when you're doing stuff, if you're like loading an agentic system onto like one of these like new cloud like neo clouds where you can kind of get near bare bones
Mhm.
and you're trying to talk from data center server to another server, this is stuff to consider, or at least how
Yeah.
you're organizing how it talks. Ruth, I saw that you have like a way to optimize your swarms per topology. Is that
Yeah,
part of?
I
Yeah,
yeah.
I wanted to see you talk about that because that's cool.
Let's circle back to this after the top of the hour. I want to give Ryan the chance to give his presentation, but I do
Of course.
have I've created an attention mechanism, so various forms of attention based on the sort of graph topology. So it learns the structural integrity and interconnected relationships, and then applies a kind of transformer model directly to the interplay between the vector, the latent space, and the graph implementation. That's a whole other thing. So that's like the next level of your research to dig into. It's like which attention mechanism. I've created now
Oh,
more than 100 different attention mechanisms and transformers dedicated to just this.
really?
Yeah.
All right, we have to talk about that later.
All right.
Awesome.
So
Yep, Ryan,
nice. Yeah.
Hi,
super.
everyone.
Hey,
Ryan
Ryan.
Smith. I'm in Vancouver. Spent a lot of time with David Graton here, and
Oh,
having a
sorry, Ryan, just one moment. Scott, can I get you to stop presenting there? And we're going to switch over to Ryan so he can share his screen. There we go. Sorry,
great,
Ryan.
all good. Yeah, briefly, my degree when I was in undergrad was in experimental physics. Spent some time at Stanford, so everything you were just describing earlier, Ruve, is just bang on. Just like all the original numerical methods, understanding the latent space, getting shape and structure. I don't know anything about what's in the container, but I can back out from observation. So theoretical physics versus experimental physics divides on that principle. And so it's just really interesting to see where we're at now that we have the compute to back out from observation, no matter what's in the container. So awesome. Briefly, I'm at the stage now where I'm starting to hit limits. Running on my MacBook M4, running things in Docker. I see what like Jed and others and you are doing with like K8s and TMUX, and I'm like, whoa, like I'm not there yet because I'm not actually a software engineer, and I don't actually understand DevOps and CI and testing harnesses. There's a lot of training and human skill I don't have to build out production scale software. And what I'm doing is backing out the skills I don't have, researching it, working with Claude, asking others what they're doing, and then starting to get more of a deterministic harness through skills that I can then use Claude Flow and like level up the things I don't know through that like layer of documentation. But what I'm finding is the cost of skills can be quite high in terms of like the economic cost. So I'll show you like current status here. Um, the way I'm starting to think about skills is like progressive disclosure, like lazy loading, the minimum amount of um, instructions for using linear, and then some like scripts that that skill has accessible. So like markdown file minimized plus um, scripts available for specific jobs. And then further to like the topology conversation, thinking about skills as topology. Skills would naturally have sub-skills in certain cases or mesh skills in certain places. Skills can naturally be daisy chained. There's a sequence of skills that would occur, each of those skills being executed by a subagent, which is the Claude Flow infrastructure, right? Queen bee, parallel subagents, SQLite, being able to facilitate the communication. And then for each sub-skill, sub-agent, what skills do they need and various sub-skills in topology, right? Skill, sub-skill, or daisy chaining skills, which then may be facilitated through other sub-agents. So that's kind of current state thinking through the initial high level, more like a header file. It's like less than 100 lines, structuring more full skill content, um, establishing these daisy chain patterns. So I don't want to load 500 lines for every time a test agent needs to do something with React, right? Or like with Python. Like what kinds of tests and structures am I looking at for my code base? I can specialize them and then give them certain structures. Let me back out of here because I've actually productized this using Cloudflow. I've put it all on a public repo. This one, there we go. So I've structured it as Skillsmith. It's got a MCP. There's also a CLI. The CLI is really intended for creating skills. The MCP includes the vector database. And so I'm scraping GitHub for all skills, publicly available, and MAT licenses. I see about 80,000 of them right now. I don't care about overlaps. I want to curate the skills so that as I see certain skills being ranked up in terms of number of stars, those should be emerged as the reference skill in that latent space. Now I can get rid of the cruft, 80 other linear skills I don't need to see. I actually just need to see the top skill in that space. And what is it about it? This is starting to back out how to A, construct skills, and B, how to organize skills to work together. And then so having a vector database of skills now, which is included in the MCP server, means I can bring that MCP into a repo and have it understand the requirements of that repo and where skills should be applied, or to help refactor the skills.
Nice.
I'll pause there for a minute.
So nice work, Ryan. This is awesome. And what this reminds me of a little bit is the MCP update they did in December, where they did that kind of lazy loading of tools. So rather than loading all the tools and filling your context window, it only loads the details of the tool or skill if and when there's a requirement to learn more than what it's described as, like the title. And you're kind of doing that. You're separating it and allowing it to be more incrementally discovered and used. Is that the
That's the
takeaway?
idea. I actually, following what I saw you post about the other day, I really don't like MCPs. I feel so like they're flaky, they time out, like they do a lot of things badly. But when I want a live server sitting there while I'm working, and it can be a reference, like a second brain, specialized in skills, then it's a really good use case for MCP. What I actually really like is like through the CLI. Now in Claude, I want something done. The Skillsmith CLI is then available. It can spin up a parallel agent with a skill, execute, and then die. Like that's actually the behavior I want a lot of the time. I don't actually want to be running everything through an MCP. I just want the MCP to have the vector DB for like real-time communications. So I'm starting to rethink like the topology of when and how to use skills versus MCPs. And I'm in a big like minimization effort of MCP use, specific use case here, so that anytime any agent is spinning up and sees something that it needs, it can go and grab it off the MCP. But sometimes I need a CLI with arguments to like go and do something specific. On the linear agent I've been building, for example, it has rules that like modify the CloudMD file, a parent linear skill, and it will always spin up a parallel agent to then go execute the linear skill, getting it out of the prior agent's context window. Right, you don't need that context in the whatever parent agent execute, like the coder agent. Code's done. Update linear. But that doesn't need to happen in that first agent. Just parallelize an agent. That parallel agent can just execute that one linear action, die, come back, job done. So I'm getting this like cost function minimization through this structure.
The I like what you're doing. I think you're thinking about this the right way. I'm picking on MCP a little bit because you pound my head against it a little bit on my projects. But yeah, as you point out, for most the things that I'm doing, especially if you're using a command line tool, using CLI is faster, more, and as long as it has a proper exit, like an exit 1, 0, 1, 2 kind of thing, it's faster and easier to interact with. So the verbosity is optional if and when the CLI tool is called. Otherwise, it doesn't really need to worry about that in the way of MCP. But for MCPs generally, it's great when you're trying to integrate it with like a desktop app or a chatbot or something. It's perfect. It's perfect for that. But for agentics, for building agents that need to interact with other systems, it's kind of dumb.
Yeah.
It's cumbersome, it's slow, it has no concepts of security, it can be easily exploited. It's vulnerable in many ways that you don't want in anything that's autonomous.
Yeah, thank you. I'm sorry to demo and run. I have a 10 o'clock presentation I'm doing. I'm really keen to get crit and find the issues. This is 4 weeks in. I started this December 22nd.
Nice.
Fully deployed, documented. It's all up. You'll see there's a hosted live service that's running with this. So right now, my credit card, all the like compute to scrape quarantine skills, run through a security vetting, put it into live services. That's where you see there's an API call, because right now I'm paying for the live services to make sure that the vetted skills in the SQLite DB are matching standards that I'm seeing off Anthropic's security for plugins. So I did a bit of work there. And at some point, this should be structured more like Docker. Free for everyone. Here's the code base for life. And then as you hit certain like API calls, like you're using this in a company and you need like to be pulling off live current skills, which are changing by the hour. My job right now runs every hour. Sees a skill has been updated in the DB. That DB can then be pulled down. It's only a one-way pull. No data goes up. And so I got a little live services there running similar to the Docker model.
And how many skills do you have aggregated so far?
Just over 14,000 are curated out of a 80,000 base.
Good job.
Nice.
Great.
Cool. Thanks, everyone.
Fantastic.
Ryan, can you drop your URL before you go?
Oh,
Your
sure.
repo?
Yep.
Yep.
Skillsmith
In chat.
app. Yeah.
Yeah,
if you hit that, if you just hit the docs in the top right-hand corner, I just set it up as like a little like screener. But you can just hit the docs and you can access everything.
Thank you.
Okay. Thank you, everyone.
All right. And Dragon, I saw your update earlier. You wanna give a quick demo of what you've built? Looks pretty cool. Putting you on the spot here a little bit.
Yeah, don't worry. I'm up to it. So just let me. Yeah, the professor.
The professor is always ready to lecture. No, let's. I'm very impressed with what you're putting together. It's a nice sort of alternative. I like it.
Yeah, I will use the presentation created by Notebook LM about the new version, because it's really neat one to present in short all the changes, and this is like a complete rewrite in 14 days using Cloudflow v3. So let's see the results. So what we are solving. Multiple things using the building blocks provided by Ruben. His tiny dancer, reasoning bank, zero log n speed, that's the HNSW, I think, used in that case. So, solving multiple problems using the tools. And we are doing that now, also applying the domain-driven design. And that's really fits quite well into multiple, in this case, 12 domains related to the quality. And they're organized in this way, from the test generation, execution, coverage analysis, assessments. So, you get like the full cycle covering whatever needs are in the software development lifecycle, but not anymore in the just classical way, but preparing the world for this agentic way. With the amount of code produced, we need better tools to be able to assess the quality provided. Again, couple of concepts from the Cloud Flow. And Dhruv was just explaining the Queen coordinator concept. In this way, this agent organizes and manages the consensus, the fault tolerance, and workload distribution across all the concurrent agents, and invoking only the agents in the certain domain. And as agents are working only inside that domain, they are allowed to go deep instead of wandering around wide. The brain is I'm using RuVector. This is like a combo. This is part of it from the AgentDB. So the reasoning bank is from the AgentDB, and the dream cycles. I think also dreams now in Cloudflow v3. I think you implemented the dream cycles, but that's something that I already had in v2. I think Farshid or somebody already introduced that concept of nightly learner. So I just applied the nightly learner, and mixing 9 reinforcement learning algorithms, also provided in Cloudflow. Tiny Dancer for intelligent routing. So complex tasks go to the APIs with the highest cost, to the Opus 4.5. Moderate cost for the bug fixes and test generation, and Haiku models for the syntax fixes or just type addition. And this is something I need to benchmark properly to verify it's working. Some using the Johnson-Lindenstrauss gap detection, or this is that logarithm for an logarithmical analysis to get faster coverage over increased sizes of code bases. And as the repository size is growing and the complexity is growing, with the standard linear analysis, the time for analysis grows significantly, but with the logarithmical, it stays, the same. There is 50 new agents. There is, a lot of them. You can check the repo later, and I like this representation that Notebook put here. Also, my re-implementation of the TDD red-green refactor cycle available as 7 specialized sub-agents dedicated only to the TDD lifecycle for those that want to use it. One command, full release validation. So you can, ask the Queen coordinator to orchestrate the complete release, and it will invoke needed agents to do the preparation, test generation, gap analysis, and different types of scans depending on your code base. It will give assessment and go or no-go decisions at the end. Native integration with Cloudflow and other NCPs, and today one of the releases was adding your Cloudflow browser with agent browser integration. So Visual Tester now and other agents in the fleet that are for end-to-end testing can access now and use the Cloudflow browser to run the UI test and to, and not only that, next to that, there is for the lighter tasks that should be more token saving, there is a Vibium integration. So the Vibium is the guy that created Selenium, now created Vibium. That's the new UI automation framework dedicated to agentic development, and it's still in development phase. So, I expect it will provide more functionalities, and right now provides just the basic ones to start with. It's all these agents are, let's say, induced and intertwined with the skills library, and some of them I see already in community are getting traction, like the brutal honesty review and 6 thinking heads, and a couple of more like context-driven testing. And yeah, there is a lot of interesting skills. And what the fleet, the whole QA fleet, is specific for agents and skills that are allowing uh, quality control of Nathan workflows. So I don't think that there is any tool right now on the market that can allow, if you configure and ask the cloud to use the Nathan agents, and you add like an API key for your, if you have a cloud or if you have your on-premise Nathan instance, it will work with the on-prem. So it's configurable, and yeah, that's a neat feature to have. From V2, like with, I don't know, more than 5,000 files, we are down to 550 files in the V3. And that's also something I took from Ruben. So having a lot of things, just on a pile created a lot of problems in maintenance in the old version. So that's why I decided, like, okay, let's completely rewrite. And Cloudflow version 3 really, helped me, do that in 2 weeks. So
Amazing.
just npm install Agentic QE Fleet latest and use QE Queen coordinator or any agent or skill. And yeah.
And by the way, Dragon, just to let you
Yes.
know, I've got a plugin coming for QE Fleet
Woohoo!
in an upcoming release, maybe later today if I get to it. So you're going to be my first external plugin, and it'll be an example of how you can, it's almost recursive in the sense that it's built on top of itself and optimized, and it's amazing plugin. So all the features you just saw, you'll be able to just invoke directly.
And
And
one more thing. Yeah, sorry to jump in. Yeah.
It'll upload. Sorry, one last thing.
Yeah.
It'll increase your downloads.
Ooh.
There you go.
And I'm working on coherence layer using your, Prime thing, also as we are speaking, the agents are implementing that. So, probably tomorrow morning we will have the new release of the first agentic, quality engineering fleet that offers the coherence architecture, coherence gated quality engineering with Prime Radiant.
Nice. We're like so into like this crazy AI. We're living 50 years in the future.
Yep.
It's amazing. I love what you're building.
Glad you have your hands up. A question for
Yeah,
me,
I have
maybe?
a question. I have actually a couple questions for both of you. I mean, first one, it's interesting you mentioned Sonnet because I was stealing both of your work and trying to come up with my own. I found Sonnet completely useless because Haiku is great if you want to do something fast and something very dumb, like if you run like unit tests and basically see like did they pass or not, like right. Haiku is great for that, and like Opus is good for whatever Opus is like for complex tasks, right? I could not find the niche for the Sonnet. Like it's somehow like it's slow and expensive, and it's also like does very dumb things that the whole system basically have to go back like in the loop again. And so what I noticed with Sonnet, right, it messes up and then like I have a recovery mechanism, but it gets triggered a lot. Like so, Opus usually like if you even if like simple things like writing tests or writing code from the pseudocode, somehow Opus writes it correctly. It doesn't need to be refactored. Then I see like the Sonnet like output has to be refactored a lot. So when do you actually use it? Like
either like for the things that are quite like a middle range, it is like a bug fix, but it's like when it's like a straight bug fix. And if Sonnet 4.5 is not really, that bad. We used to
No.
use it, like 3 or 4 months, ago, before the Opus went out. But
Yeah.
yes, it needs more correction. I agree with you.
Right.
And probably
But
the iteration loop. So I also added like a skill there that
uh-huh.
mimics the Ralph Wiggum technique. When needed, it will iterate more on a task when
Exactly.
with this. But again, I need to measure. You're, quite correct, because token consumption, maybe if I need to iterate more times,
Yes.
is not justifying, using the cheaper model if
Right.
it, will burn more tokens in the end.
Exactly, because Sonnet is half the cost, but it messes up like the Opus. I noticed it messes up very like rare, and Sonnet does it a lot, so I have to go through the loop like 2 or 3 times, like, and that's actually becomes 1.5 the cost, like if I use the Opus all the time,
Yeah.
like.
So
That's,
I use mostly Sonnet because
use mostly Sonnet? Really? Interesting.
I can extend my system dramatically, like in terms of usage every week. And the way that I'm doing it is I start with Opus 4.5,
Mhm.
and then at a certain point in my project, usually several hours in, I get the sort of coherence that the system now is trained, and I see the
Yeah.
little brain icon is like 20% or so. At which point I'm able to then switch to a lesser model, but maintain the level of capability from the original model. So what I'm doing is a form of transfer learning. So the first bit is basically training the system. Now I can jumpstart that whole process by using, at least in the Cloud Flow system, the pre-train option. The pre-train option will essentially review your entire repo and then train the vector space on all the information it needs. Now, the important part of the pre-training, especially if this is a repo that existed beyond the first day, you can actually train it on all the commits ever made, all the updates, all the fixes in the GitHub repo itself, and that also can form the basis of the vector itself. Now, you saw that Dragon mentioned Tiny Dancer. The Tiny Dancer, essentially, when activated, can then autonomously make the decision of what model it should use and when. And the further you get in, the lesser the model required. So by a week in, I'm fine using a really crappy local model because I'm hyper optimized it just to do this particular project.
Oh, maybe I'm not. I think I got the sort of good behavior basically on Tuesday. I'm not a weekend, so maybe that's
Could be, or
my thing.
maybe I didn't activate it.
But
No,
actually, just to
they
follow up
had a
on
lot
that.
of problems, in the last couple of days, definitely Anthropic, models. I'm, subscribed to their status as mails, and I'm constantly getting, like degraded status errors, problems with all of their models, in the last 3 days.
Oh, okay. I mean, I got actually, I don't know if you guys in Amazon actually using the all the Anthropic through Bedrock, and it's somehow like more stable than Anthropic like actual ones. But another question for you: have you tried to experiment with open source models or like a cheap models, like a Kahiri or Qwen, because they might be like a good replacement for the.
So yes, I've released my own model. And it's using an RLM pattern. I called it Root Ultra because I named it after myself because I'm lazy. But basically, this is a derivative of the Gwen 0.5 model. But it has the auto learning. It's got the classifications. So, and it's super fast. And this is how I avoid having to use any secondary model. This thing is only, I haven't quantized it because it was so small I didn't really care about it. But this is around 400 megabytes. If I quantize it, which I'll do at some point, I could probably get it down to about 60 megabytes. But it's amazing. But it's not amazing at everything. It's just amazing at Claude code and nothing else.
Yeah, yeah. I found for like lots of tasks like this, like small Chinese models are like beat everything. Like if you consider the costs.
Yeah, Chinese model Quen is the only model you need to worry about. Here, I'm gonna give you guys a couple links if you want to run. I bet the entire inference system as well, so you don't need a Llama or Llama CPP or anything like that. Everything you need to run this and train this and optimize it is contained within this crate. I got a WASM as well. I can share you guys a
I
link with
also
that.
people say good things about these Canadian models. I think there's called Kahiri or something. It's the,
Yeah, they're Toronto guys. I haven't heard much from those guys lately. I think they're living their best lives as billionaires.
Oh.
I
No,
don't
but I
know.
heard they're good for like not for coding, but if you need like narratives, like it's they beat like a lot of.
Yeah, they're popular. Yeah. Actually, guys, I want to show you guys something quick. Some people are asking about like Notebook LM. I want to show you that quick, like the trick. I found a bit of a trick to Notebook LM. Maybe others already know it, but they're like, how do you get it to look like the way you want it to look, right? So this is my Claude Flow. It looks like my Claude Flow, right? And if you go back to Claude Flow for a moment, so I've got this sort of graphic I use. It's kind of a neon, whatever. So I want it consistent branding. So what I did to do that is I go into ChatGPT or Claude or whatever, and I basically say describe this image style, and that gives me a neo whatever, and then I grab that, and then I go into Notebook LM, and then I always click the little pencil icon here, and then I choose concise because if it's small and square, so it fits on LinkedIn. And then literally I didn't paste that in there, but literally I'm just pasting in this description, and I'll choose detailed for this, why not? And then that results, and then you can do this also for presentations, but it ends up pretty good. It's pretty close to the design structure that I've already set forth, right? It's not bad at all. And so basically find an image you like and ask ChatGPT to describe it. Right? Not too bad. This is wrong. Hallucinate that. But anyway, gotta double check Notebook LM. Kind of a oh Matt, you get a question?
Yeah, two questions. So if I want to build with Cloud Flow, it's for you and Dragon. If I want to build with Cloud Flow, but use QE Fleet, what's the best way to invoke or trigger? Do I start in QA Fleet and QA Fleet has Cloud Flow baked in, or
No, how I do it. I use Goal Planner to create a plan for implementation, whatever. So you have, something already ready. And then I ask, based on this, use Goal Planner to create me implementation plan that will be executed by Flow and QE agents. And that's it.
Yeah.
Okay,
Yeah,
perfect. That's what I need.
it's interesting that you're using exact. Oh, can you guys hear me? Am I breaking up a little
Yes,
bit?
yes,
Yeah, I can
yeah,
hear
yeah,
you. I can
yeah,
hear
we
you.
can hear you.
We can
Oh
hear
yeah,
you.
you're using exactly the same approach that I'm using. Here, let me show you. I just resumed the implementation of QE to show you how I did the QE. So, all right, so we've got okay. I started it right here. So basically, let's scroll up, create a new branch, explore the following npm. So I sent it directly to his npm library for integration as a plugin with Claude Flow v3, create detailed ADR DDD, and I used the code goal planner agent. It did its thing. It ran the code and then created my ADRs. Now I didn't ask it to implement, but it did actually create a plugin. I'll review that here in a minute. Oops, and why can't I? V3 implementation, so I'm not sure why it's not letting me click it. So I'm gonna go here for a moment.
It's something happening with Visual Studio Code. I'm having also problems opening links recently.
So ADR 30. So that's what we got to look at. So now I get
Ooh.
it. Now I get the ADR. So we go here and there's a branch that you guys can go check out because I have auto commit turned on using the GitHub integration. So every time it does anything, it auto commits to GitHub. So it's already in a sub. So if you want to see it, but you can see the problem statement. V3 requires comprehensive quality engineering capabilities, which Dragon has done a great job of. Here's now I did the analysis of the package, 51 QE agents. Seems like that might not be wrong. I mean, take a closer
No,
look.
it's 51. I added new one. Yes, yesterday. So it's not in the. Yeah, so it is 51. Good number.
So now, but we see the shared dependencies, which is really important. That I already have
Mhm.
these dependencies, right? So this is really useful. You're using my transformer components. Here's the flow, right? So it's got everything I need here, ready to go. Now, before I go and finish this off, I'm not. I'm going to review it, obviously, which I'm doing right now with you guys. But then I'm going to go back down to the end here, and I'm going to just basically say what's missing from the QE Claude Flow plugin. That's it. That's always my last stage before I actually implement it. And that's going to go and basically tell me what I need to know. Now, I actually have a fix for this. I haven't actually implemented the fix where it does these weird lines going up like you see here. Because I have a custom status line I'm running just for this repo. But this is also telling me some of the information that I need to know in regards to where I'm at. Is it secure? Yeah, what's integrated. Now, the updated version of Claude Flow has a much more in-depth version of the status line. I don't need all that stuff for this. I'm just more curious to what it actually needs to build. All right, so it says it's missing some stuff, missing some implementations in terms of entry point. So you see why it's important that I asked what's missing. Even though it was pretty detailed ADR, it's always going to find something, right? It's so in this case, okay, that sounds good. Update ADR and plugin plugin plans. Now I'm going to remind it, don't implement yet. There's a tendency to want to implement.
While
And
you're
you
here,
know,
Ruth, this actually leads into my other question. So V3 has baked in what Tiny Dancer, Root Vector, etc. What is the best way to give the system autonomy to choose when it needs a certain plugin or capability, or should we declare
ask
and
it.
how do we ensure that it
Ask
uses
it.
Root Vector? Okay.
Just ask it.
Thanks.
Don't ask me, ask the system. The system is intended in that's what appears what Dragon's done. He's basically asked the system about itself and said, how can I use it as part of what I'm doing? And I think,
Exactly that.
right? And that's
Yep.
the purpose
Yeah.
of the system.
How I can use this in my context,
Yes.
and then let's see, and then tweaking a little bit. Okay, this is the way, and do it.
Yeah. Jose, you got a comment?
Yeah, I have a question about Prime Radiant. I think it's a very good use for Dragon project. I think he mentioned that he's gonna use it or implement it. But I'm wondering, are you gonna set it up in the root vector by default? Is that something that will be implemented in root vector? I missed the first part when you were talking about it. Roof?
I'm in terms of where I'm implementing QE or
The Prime Radiant.
It's a package in Revector currently.
Correct.
And it's I put it in three places, but the two places that matter, I've included in my attention WASM. So the attention WASM that gets distributed as part of agentic flow and as part of Claude Flow. So now it gives it the ability to understand coherence natively in the system. I haven't published that yet. I might do it with Dragon's update later today. And I've also have it implemented as a standalone package that you can just use and pick and play, kind of like all my other packages. That's in the crates and NPM.
Okay, then in that case, have to be implemented in different places. It's not like you implement it in root vector and whoever is connecting to root vector will use it. So Dragon have to implement it in his system. You have to implement it in Cloudflow, or we have to pick it up.
Root vector is the bottom of my stack. It's the foundation. Yeah, and then as it percolates its way up, I have to explicitly include the packages. So I don't just do at latest because that's problematic given how much stuff I build. So as I do each new layer, let's say the next thing I'll probably do is update the attention WASM in Agentic Flow to have the most recent package. Then I'll test it, optimize it, benchmark it, fix any issues that appear if there are any. Once I'm happy with that, then I'll go into Claude Flow and then I'll do the same thing. Claude Flow is the last step because it's the most popular. So I'm the most I end there because I don't want to break the experience because get too many people complaining about it.
Okay.
So yeah, the cutting edge is the bottom.
Yeah, but then Dragon don't need to wait for you to implement it in root vector or integrate it in root vector.
No,
He
he
can
can
go
I'm
grab
using
it.
the package already as it is, you know, Ruven published. I'm using Wasm, you know, not the crate, but the Wasm, you know, package, and I'm just integrated in npm install, and it's part of the package. And now I'm adding it in the proper places in the quality gates and the things where it will need to validate, you know, claims.
Okay,
Yes.
understood. Thank
That's a
you.
good point that Jose is bringing up because it talks about whoever wants to build modular capabilities on top of root, root vector, QE fleet, etc. Yeah.
Correct,
Yeah,
because
so
right now so many packages, one in different layers, that sometimes I feel like if you have it under, I don't need it in the top layer, but actually it's not like that. So I know you have to connect it somehow. You have to wire it, but
yeah, so here's
yeah,
an
go ahead.
example. So in this case, I'm gonna skip a step. I'm gonna implement it directly. So in this case, I'm gonna say create another ADR 31 and explore the integration into Claude Flow V3 as a plugin. View this, right? And then at the end of this, I might do at goal. Now I'm going to use the code-centric goal orientator because it's a coding project. And that's it. And I'm going to start that, and then I'm creating another ADR. And then as part of that, then I'll be able, once I'm happy with that ADR, I can essentially implement both ADRs at the same time. Now, if I wanted to, I could create work trees for both and have them work concurrently, or maybe I'll just build one and then do the other. Oh, I'm compacting. But yeah, that's all I'm doing.
When you say Rube, when you say create an ADR, is that triggering an ADR skill so that it's going to go?
Yes.
Okay.
Yeah. It knows my skills. So it's got all my skills. Again, when I say this is built for me, it's built in the way that I like to work. So when I say create an ADR, I don't have to say use the ADR skill. It just knows that that's the skill it needs to use.
If you don't ask for it to use an ADR, is it not going to make one? Like, so you're
It
consistently
has a
doing.
it has a tendency to make ADRs because my system is constructed around an ADR and domain-based architecture. Um, to be honest, I don't know because I'm so in my own little world of using my system. I sometimes don't know what the world looks like when not using my system or using it, in more, without, different guides or whatever, right? So I don't know. I think it does because I've got the Claude Code, aware of its own sort of capabilities. So my sense is it probably would, and when the projects I see people building on my tools all have ADRs now, so that says something.
Okay.
Hey, quick question about I think to Ruven. What's your technique when I saw like it's been compacting, right? To actually skip on track after it compacted because sometimes it goes sometimes it's even better
Yes.
after compacting and sometimes it
It's
gets
actually
very
better
hard.
for me. Mine actually improves after a compact. But here's what you need to do. So in your Claude folder, you've got the settings.json,
Uh-huh.
and I've given you sort of my default. This one isn't actually default. This is optimized for this particular repo. But you'll see here that there's different options for pre-compact. I think stop. So I'm injecting information at those critical points that guides the system, keeps the system from drifting, keeps the system from
Oh.
doing, what it shouldn't. Now, this one here is particularly optimized for this environment. This isn't what you're getting when you do the init in Cloudflow. This is
Uh-huh.
for me. So I've got
Okay.
like the hyper optimized version. You see, I've got timeouts occasionally. Timeouts are important when you're using MPXs or MCPs as part of your hooks. You don't want infinite time to live on that. So this is setting about this is 4 seconds, I guess. Yeah, so you've got you see I'm using the MPX. I'm using the MPX here now because I'm comfortable with the platform, and it also kind of tells me when it breaks. So when I do if I publish something and I accidentally break the MPX on agentic flow, I'll see it right away. So again, see how it's cascading? I'm using agentic flow as my hook here. And the agentic flow system has all the same and more capabilities as Cloudflow. The last thing you want to see here also at the very end, this is arguably the most important thing you're going to want to do. You don't want it to say built by Claude every time there's a commit. Without, unless you define the attribution, you'll see it says built by Claude. This now you're saying it's built by Agentic Flow or Claude Flow, but you can replace this with yours. Make sure your email address matches your GitHub repo. Otherwise, it doesn't work. But this is how you enable it. And yeah, this is how I do it. This is in the live repo, so you can take a look at that file. You can see I've got environmental variables.
Great. Okay. Okay.
Yeah,
That's good. Because I noticed that gets better if you're going deep into this rabbit hole and it's actually gets hyper focused and it doesn't actually need that prior stuff, whatever had in the prompt. But if you're jumping like in a loop, like over like different tasks, that's when it gets dumb, like because it. So maybe I'm not organizing the loops correctly. So that's
also, if you're using this just in the Claude Code web, remember that you're going to have to probably just remind it. It might auto install it. It usually does, but just to be on the safe side, if it's a new project, tell it to npm, Claude Flow, at alpha init, and then it'll initialize all the hooks and plugins and skills, and then your Claude Code web becomes super smart and capable. Half the stuff I do, I just do in web when I'm.
When did Claude ditch 10 p.m.? Just was it yesterday or today? They don't.
Yeah, 2 days ago.
2 days ago, yeah, because I noticed that. Are you planning to have a native?
Do I need a native? Like what? Like let's look. Why
I
did they
mean,
do
there
that?
is cheap way. There is a packager called Bun, like it makes like very tight native things out of.
But it doesn't. There's no performance benefit. There's some installation benefit, but I don't run into that problem. There's the native tool. I can't find any reason to use it. Everything I need to do native, I'm doing with WASM, so I don't really care about that. I don't see. The only reason they might do it is because they're big enough and they don't need the distribution of npm, or they want to control their own distribution.
Right.
But there's no real technical reason that they're doing it that I can
But
see.
you have dependency on this whole npm machine, so if anything happens to it, then
Yeah, but I also can install npm on Windows, Linux, on edge devices, Mac, Intel, ARM. I've got no issue. I've got full coverage on at least 7 of the most large environments without any problem whatsoever.
Okay.
Wait, right? As long as it supports npm, which you can install everywhere.
Yeah.
And again, it's default on Windows now, so you get npm even when you get to buy a new Windows.
But I found myself actually fully committed to Go right now because Go files need no like they just files. Like you just basically copy the file. It needs no like anything on the target machine.
Yeah, Go makes sense. I have a preference towards Rust because I sit a little closer to the sort of temporal loop.
Yeah, I had problems with Rust, like the binaries when it has dependency on C library. So if you get some obscure machine, which I come across like once every month, like the binaries won't run, like unless you like, and you have to go and see live.
The WASM won't run it. It should run.
The Rust, WASM, no, but WASM you need the whole node and friends, like. But if it's
I can run WASM on a chip. You can run anywhere.
No, but what runs WASM? I mean, it needs runtime, right?
Yeah, but it's tiny. It's like 8 kilobytes.
Yeah, but with Go, like you need 0, like and it could be like some FreeBSD machine from like 20 years ago, and it would still run like.
Well, if I can run it on this. What else? What else I need? What else did I tell you? This is $8. This is
No, but it's not the power. It's the ancient C libraries and kernels and stuff. Because even if you like an Arduino chip, you have latest and greatest like everything it would run. But if you found machine that's like from 20 years ago, like that runs OS like from a very long time ago, that's when you hit the problems. Like
I bet you I'm gonna maybe we do this on our Vermont getaway. But I bet you if you got me a 286 processor with 1 MB of RAM from like,
Yeah.
1983, I bet you I could get AI running on that.
No, you can. The problem is it's not the computing power. Problem is you have to stay on that operating system and you cannot change anything about it. And you have
Yeah,
to use the libraries and DLLs from that OS. Like that's when
I'm
the Go need doesn't need anything. It will just run anywhere. Like it's
How did you know that's what I was running, Roof?
I can make any old computer super fast by just getting Claude, to connect to it and then optimizing it. It's basically, the problem we have is we don't build software for efficiency. We build software for the sort of, growth of the resources available to the software itself. So there's, Windows is bloated not because it has to be bloated, it's because they're lazy and said, you know what, we've got more CPU, RAM, and storage available and GPUs, so therefore we'll just, make this thing even more bloated. Now, the reality is what we're really doing when you look at things like Rust and Go and saying optimize, 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 is we can get these systems from bloated to hyper tuned and hyper optimized. And that makes a 10-year-old computer, a 10-year-old Mac Mini, in some ways just as fast as a modern Mac Mini for certain tasks anyway, because it's optimized.
I have this pet project and it's kind of like not happening because the way like people run, there is this whole retro futuristic look. So I was trying to get actual retro computer to run because all you need is a terminal, right? And you have all the code like on the back end.
QEMU.
But
is
these
what I
things
use.
are so expensive, like because VT100 now it's like $2,000, and when I was in college in the 90s, I bought it for like $20.
Yeah, if you're the way I do it is I start with the QEMU program that allows me to
Yeah.
emulate different environments, and then I just basically emulate the ESP32 or whatever chip I'm trying to
No,
work
but
against.
actually, I was gonna get it on a real CRT machine with CRT display, like the actual retro computer, like not
Let's do it.
emulator. But those
Do
are
it.
very hard to find. Like they're like thousands of dollars, and they super heavy. Like
Oh,
that.
I've got a basement full of old computers. My wife's like, why don't you ever throw away your damn computers?
How
So
old? Like are they from the
20
80s?
my old 80s computer, probably not, but I do have computers from like 25 years ago. So
Those are
I've got some
not very. You need to keep for
Pentium,
another 20 years. Like, but
probably Pentium
computer
1.
from 80s is like $2,000-3,000 now. Like it's.
I gotta ask my parents if they've got some
I've
of my
got
old
some
computers here.
I've got some Toshiba laptops on a 486, but I don't think I've got anything older.
Yeah, I
No,
got
I
a
need
486.
before. I need like 16-bit machines. Right, those are like or 8-bit.
ZX Spectrum.
Yeah, I really like the way you mentioned Roof at 286 as an old computer. I mean, I remember when an AT was a really new, the coming thing, an AT. I remember it was, you used to work, everybody was working on an XT, and these were these ATs coming out. If you had
Well,
mentioned an 8080 processor, now that would have been an old one, but at
well,
286.
I'm 47. I'm 47. So my first computer was in 1986, and it was a 286 Tandy with basically nothing in it.
Very
I
modern.
find me one of those. Yeah, it's very
Yeah,
it's,
first
it's,
ZX Spectrum with 32 kilobytes of RAM.
There you
That
go.
was my
Yeah,
first.
let me tell you one.
My
I have a TI 9948 Texas Instruments TI 9948.
Let's put some AI on that and let's see. You know what we should do? We should see what the oldest possible machine we can get AI running on, like with some basic attention, and have like a competition, like a retro AI. I'm sure we could get this thing working on something from like the 1970s.
Yeah, I was actually this morning. I was pricing the IBM like line print. The line printers with typewriters. Those are like thousands of dollars now. Like and then.
Well, we need one of our crew to become a billionaire so we can buy all this crazy stuff.
You need to rob one of these computer museums. So maybe I don't know. Maybe collaborate to
No, I
them.
think Roof's suggestion was better. One of us become a billionaire. I think that's a better
Well,
suggestion.
the whole robbing thing, I would be really bad in jail. I'm not really built for that
Okay.
sort of place, and I'd be really bored. Like imagine me sitting in a cell all day. Like what would I do? Yeah.
Yeah. But maybe you can collaborate with computer museum, and if you get the code running on the.
Actually, I have a friend that's on the board of the computer science or the computer history museum in Silicon Valley. I should reach out to him and see if he might be able to do something together. I'm just too lazy to go to the Silicon Valley. It's too hard to go through the U.S. customs. But regardless, we should totally do that.
Yeah. And actually, I found that there was some things I found in California on eBay, but those things, the old computers are so heavy, they cost like $500 to ship, like.
Yeah, that's for sure.
If you're running
But,
an LLM locally, we talked about a bit about the whole AVX 512 stuff, but like, what are people practically using? I'm thinking like a PC parts picker, so that you can upgrade a computer given economic situation right now, which is like RAM's expensive, but you probably are going to want to stick a ton of RAM in it later. So have we got some PC part picker favorite builds? Would that be something that people would be interested in?
yeah, I would be. I
Okay.
love the idea of custom AI kit. I think that your thread on Discord makes sense. I'm focused on this size. This is a Raspberry Pi, but this is the top end Raspberry Pi. It's a couple hundred. I think it's like 300 or 400 bucks. But this, for me, is everything I need. It's got my USB ports. It's got USB-C ports and mini. I've got I've got my 10G router in there. It's amazing. I can run a 70 billion parameter model on this thing with a touchscreen, and I just pile them up, boop boop boop, and they all communicate with each other. And I got a swarm of Raspberry Pis. The
So
latest
if we
Raspberry
make a
Pi, by the way,
channel, like what are we going to call it? Hardware? PC parts picker? What would be like a place? Of course, I'm
That
going to say
would
in Discord.
that would also roll into robotics and IoT stuff.
Physical AI.
Yeah, robotics, IoT.
Oh, low end.
Well, I think both are valid, and I think they're separate.
I want to build. I also want to hack old systems. So it needs to encompass.
We need a category with hardware, right? And then inside there, we're going to like have a local LLM, and then a micro compact thing.
Yeah, it's chips, hardware, and other physical things. It's like the physical implementation of AI, something that encompasses those
Okay,
areas.
so I'll make a category then. So physical hardware, and then
something like that.
Chips, and local LLM,
IoT.
Yeah.
I have a bunch of projects in that space. So
What did you
if I end up going to this offsite, I'll bring my collection.
If we got Guy, he's our literal rocket scientist here that could definitely help us in that department.
Okay, I'm making the category as we speak. Physical hardware.
And I'll have those chips, at least some of them. I don't know how many I'll get in my first run, ready in March. So you guys, we can hack stuff on those chips. That'll give us all kinds of interesting things to do.
Ooh, cool.
Yeah, yeah. I'm
really
excited about that.
Thinking about you like earlier in the week, because I remember I used to drink with this college professor, and he teaches chip design. So they have access to fab because students can actually fab the chips like as they capstone project.
Like a fab like in their research department.
It's not in the research department, but they have partnership with the actual fab. It's in University of Maryland. They send their students like end of the year projects there. They actually make the actual.
I could use a an intern. The fab.
Yeah.
It's the chips are at. I'm probably speaking too much, and my partner's gonna kill me. It's at Global Foundry.
Oh, they're not gonna. Everybody is in global. It's what 30% of people in global foundry. So it's not...
Okay, yeah, it's in Global Foundry. It's
So
currently
I found
being manufactured.
I've got somebody, one of my friends. He got the job. He works at the fab outside of Boston, but that fab is very small. They make fuses or something like super dumb. Like they cannot do but there are like small fabs everywhere, and I know Maryland has access to fab, and there is a university in Netherlands. I think it's Delft. They have so if you poke around, maybe UT, University of Toronto might have it.
the Dutch have the lasers that do the 1.8 nanometer. If
Yes.
we if what we really want, if we want to if we really want to do the foundation and realize Isaac Asimov's vision, then
Yeah.
1.8 nanometer allows us to create smart dust.
Yeah, but one problem with because the Delft has access to the fabs, they got donated by what's the Dutch company who makes the ASML, right?
ASML.
Yeah,
Yeah.
so they donated the fab to the university and they were complaining about it because the cost of the materials and the running it is actually outrageous. Like, so it costs more than the fab
We should
itself. Like,
we should do something with Adafruit. They're pretty cool. So Lady Ada, she has her own fab.
Yeah.
Obviously, they do a lot of hacker hardware, but
yeah, if you
doing some
find,
product that
yeah,
they have their own equipment to run circuit boards to product lines to pick and place, and very cool.
I mean, if you make a few million chips, you can just talk to Motorola and they will fab for you. Like,
Is there anywhere we can find some specs or anything so we could start preparing for merch?
Yeah, we should totally. You can see that thing I was saying about Notebook LM. It works pretty good. Little cheesy, but
That's great.
right.
Well, this is much less cheesy than what everyone else is getting out of Notebook LM, which is
But
this
that's the trick.
standard.
I think the trick is basically find an image you like and then describe it, and then you can get sort of design
This
that
is
meets.
this is a ton better than ideogram. I would never use that again.
Look at it, it's great, right? And this is all real. Look, it says how much better I am than Crude. Crude AI is a joke. Like I don't even know why people even use that, but anyway, um, yeah, it works
actually,
pretty
the
good.
last slide was interesting because I'm still looking for a good benchmark, like, because I found that SW Workbench, yeah, it's kind of useless as benchmark. Like, I mean, it's like what
The
they
benchmarks
consider.
that 84, I'm at 100%.
No, but
But
yeah,
it's
I'm just saying
meaningless.
that benchmark itself, it's not what the practical needs are. Like, I mean, it's a number
No.
and people go, but it's
Yeah, it's BS. And then this needs a little finesse, but
if somebody develops a good benchmark for assessment of code that gives a single number, I would like love to hear. I can even like if you have idea, maybe we can build together. Like, because I'm super interesting.
I'm really into the idea of building some hardware together. We should do that. Again, in the Vermont times, maybe I'll even have some first the chips around, and I'll bring some of these random devices with me. We can hack some real world stuff together.
Oh, we did a little
Matt.
Notebook LM on your on the comments around the AVX 512. I could share that if you want a sec.
Yeah, AVX 512. So if you are going, you're likely going down an Intel path. ARM is not quite as good. You know, Neon is, if you really want to do the stuff that I'm doing, you want AVX 512. That is the requirement to really, that's more important than the GPU.
Yeah.
Well, I was wondering whether some of these data centers would be getting rid of Xeons and what have you that would have the 512, and it would be a comparably less expensive thing than.
That's my source of hardware. It's to go to eBay because their companies they sell like the 5-year-old servers from data centers, and
Well,
you can get them very cheap.
You won't get AVX 512, I don't think. I think it's relatively new, like last couple of years.
No, I think
hang on,
it's 5 years old at least. They should be coming up on the market. I mean,
okay.
Because problem is when you servers they consume so much power for what they do, so sometimes it's cheaper to get a new. Like if you look at the complete costs like of things.
I also have a thermal optimizer, so if we can also hack the firmware, so that greatly improves. We can overclock it, but then we can overclock it with a thermal limiter, so it actually monitors the min cut of the actual amount of heat versus the amount of energy that's being used in the actual core, and then we can optimize for that in using the spiking. So that takes a 5-year-old server and makes it act even faster than a brand new server.
Yeah. Hey, Roof, I was
Matt,
also.
Matt,
Yeah,
I think Matt
let Matt go first.
Matt, I gotta jump here. I got a call, but Matt, you got a comment?
Hey, yeah, Roof, quick question. Liked what you showed in Google Notebook LM. Do you know a way with audio and video overviews to have it look at a specific file and not the whole notebook? So the use case I had recently that I could not make work is we trained 10 executives, but I couldn't get an audio overview for an individual. It would continue to look at the group. Curious.
Oh, you're talking about like the audio overview or video overview elements?
Yeah, essentially we were delivering a personalized response to what we learned
Yeah,
from them.
I've gotten pretty good at that as well. What I'm doing here is, let me share my screen quick. So
And thank you.
whenever you're using these, you're gonna notice that there's a what should a host focus on in this episode. I'm putting in like a crazy ass prompt right here.
Got it.
And generally speaking, I'm going short, and then I'm stringing together several short forms, and then I'm using an audio editor on my phone because it's easy, and I just and a video editor on my phone because it's easy, and I string them together.
Thank you.
These also seem to have an effect. I'm generally using brief, but this area down here overrides the format mostly, so that's important. But you can see like the output looks pretty good. Like it looks exactly how I want it to look, right? And
Rube, in terms of how you're optimizing for AVX 512, like from what I read, when there is spiky draws, it messes with the thermals, and that's why they
I fixed
strap
it.
it.
I fixed it. So I remember MinCut. I'm optimizing, and as long as I can see the thermal data from the processor, I got two ways I'm solving it. One, it's become trivial to create your own BIOS or CMOS or firmware for the processor itself. So one of the things that nobody does is like update their own custom built firmware. You're like, oh, I got to go use whatever AMD or Intel or whoever the package manufacturer is, and that's it. But turns out, because we've got the powers, infinite powers to do anything, we can use Rust and we can compile our own firmware. And now that I've compiled my own firmware, I've got direct access, both input and output. Then I can have that self-optimizing as part of my agent flow or my whatever crazy things I'm doing. Now I'm not going to do that on a brand new $3,000 computer. I'm not that brave. But on a cheap piece of junk that I don't care about, like a Raspberry Pi, I'm modifying the core, the actual BIOS itself. Anything that's
Yeah,
malleable
but
anyway.
for the use case of like, okay, let's take an old data center server because I care less about the power consumption that perhaps that place does. I recognize that you're using the deep instruction sets that would make use of that technology, but then I don't know the applicability of this min cut. Does it
You can
apply to, for example, if
what yeah,
I'm
what I'm basically saying in the most simple terms is I'm reimagining what AVX 512 is. AVX 512 is a SIMD sort of abstraction for the processors in the computer. I'm creating my own firmware that's basically RUV 512 that's optimized specifically for my particular requirements of the of the CPU itself. So I'm looking for 512 support because I need to have the 512 bit whatever in interface, but then I'm completely rewriting it using Rust.
Hey, Roof,
You have to go
another
real
thing I
quick,
was.
Rube.
Yeah.
Do you have an opinion on the 10 torrents chips? Have you taken a look at those yet?
No, that I gotta jump, but
Okay,
Yeah.
I'll send it to you. I'll send it to
Hey,
you.
Roof,
yeah,
one last thing I was thinking about you last week. Have you considered FPGAs like as
I have.
you
Yes,
have?
and they're highly inefficient for the things I'm doing.
Okay.
I'm not my problems aren't floating point. My problems are temporal loops. So FPGAs are great for certain forms of math, especially ones that are like relating to like the inference or a sort of GPU style monolithic model.
All right.
But they use tons of electricity. They're highly inefficient beyond the sort of that core focus. I don't care about doing everything. I need to do one thing really, really, really fast. And FPGAs aren't good at that.
They're
Like
not?
that
Okay.
that narrow sort of focus that I'm trying to do.
Okay.
Yeah, I've tried a bunch of different processes. The FPGA was a sort of one of those avenues I explored that was a dead end, and I just kind of moved on.
Okay. Okay.
I put it in the chat, Ruth. It's at the tail end. You can grab it.
All right,
Good.
I'm late for my call. I'm late for my call. Yeah. So Matt, or sorry, Martin, we got to organize a Vermont thing, and I know there's a bunch of people that want to go. So maybe we'll do that as a Discord channel if you could, and update the site.
Yeah. Okay. I'll add the channel right now for it.
All right. Appreciate it, everyone. Happy weekend.